This is the engine control unit, ECU, out of a 1992 Ford Econoline van with a big block, real gas hog carbon pump. And the symptom on this is no start. And apparently it started showing symptoms of weird problems like weird transmission shifting and running rich, running lean, before it became a no start. And I've covered these before on this channel. I enjoy fixing these. I'm usually pretty good at it. I have a pretty good success rate. That doesn't mean I want to do it for anyone else, but it's always best to keep the ECU that came with your vehicle, because it has the original software that was written for the specific vehicle configuration. And the problem with these are, like a lot of stuff, the electrolytics leak. And we can see this one is no exception here. These are Nichicon electrolytics, and they always leak. And I think there were a couple people that made these ECUs, Motorola, Toshiba. And what you have to do is you have to check and see the leakage here. You have to check every trace on the circuit board, and these are multi-layer boards. And the death of the ECU comes when the acid or electrolyte gets inside the board and eats the traces in the center of the board. So usually the capacitors will not stop the vehicle from running. You could pull them all out and throw them in the trash and the vehicle would still run. Where the fault occurs, especially with a no start, is when the traces are eaten. And I believe I found it on this one. And of course it needs to be recapped, but like I said, just recapping it is not going to fix the problem. You have to find what the capacitor is damaged. And what I usually use to check these, just because I have it, is the capacitor wizard, because it's so good at measuring low resistance lines. And I believe I found the eaten trace, and it is this trace right here. I believe this is a reverse protection diode. Let me see. I believe this diode here is in here to protect against jump starting the vehicle backwards. I believe the fault is with this trace right here. You can see it goes from this positive of this capacitor to this 1K resistor right here. Then it comes over to this diode. I believe that's a reverse protection diode. If you jump start the vehicle backwards, it will pop the fuse and not the control unit. This is open right here. And that would make sense. Part of the ECU is not getting power. You can see if I measure that, we're getting like 30 ohms. So first thing I'm going to do is I'm going to bridge that. And we'll see if the vehicle starts. We'll put the ECU back in and we'll see if the vehicle starts. If it does, we'll recap it. And it'll be, what do they call it? A refurbished unit, and it'll be worth $500, $600, because that's what these are selling for on eBay. And I gotta say, it is such a clean cut. You can see it right there. See if I can point it out here. It is right here. It's broken right there, right up against the solder pad. See how close I can zoom in on that. Pretty impressive. You can see the break there. And that's kind of the B plus for the whole ECU. Alright, so there's our fix. And like I said, we'll pop it in the vehicle and see if the vehicle runs. If it does, we'll recap it. Fix it first, then recap it. Here's the beast that ECU goes in. And I'll show you the ECU is right here. It's right there. So I think we can pull the harness out and test it. I have a test ECU in there right now to confirm that this is the problem. It's becoming such a problem on this era of Ford and other vehicles that I pretty much just will go straight to the ECU depending on the symptoms. Before I check one thing, I'll just pull the ECU and look at the capacitors in the board based on the described symptoms. So we'll pull that one out and try the one I just bridged the solder. We got it installed here. See if we get a check engine light, which we do. I have George start it here. All right, go ahead, let's try it. No check engine light. Give it a little gas, see if it kind of smooths out. We should look at the emissions on the analyzer and see if it's going into closed loop. All right, we're going to take this on a little drive, and right now we're sitting pig rich. CO is 7%, that should be 0. But we just pretty much started it, so I don't know. We're going to keep an eye on that. So go ahead. Accelerate up to about 30, 35. Speedometer's not working. All right, kill it. Cut. So it's not going into closed loop. It's staying super rich. That's blowing several miles per gallon out into the air of gas. So that could be an O2 sensor problem, that could be an ECU problem. I think we're gonna change back to the test ECU and see what it looks like, because that's not usable. We're gonna test this with the test ECU now. I don't even know if this is for the right engine. Go ahead, drive it. That's leaner, but it's still not in closed loop. Like I say, I want 0% CO. So maybe we got an O2 sensor problem. Maybe the O2 sensor got poisoned from the problems with the other computer, fouled it out. That sort of looks kind of old. Also, this map sensor can go out of range and cause these things not to go into closed loop also. It's a common failure part. We're going to watch the O2 sensor voltage here. I'm into the signal. And if the O2 sensor is working, it should go up to 1 volt, and then the computer should pull it back. If it's dead, it won't show any. Go ahead, start it. Drive it. It's warming up. Go ahead, drive it. In closed loop. Drive it. Going like this. What the hell? Let it idle? Now it looks like it's working. Just let it idle. Stop. Well, it's not in closed loop at idle. And that shows here it's just stuck at 1 volt. Drive it. So obviously it's in closed loop and out of closed loop, and it doesn't set a check engine light. I'm gonna go back to the computer I fixed. Maybe I'm being too impatient. I'm back to the one I fixed. I'm gonna let it run for a little bit. Maybe cycle the key, restart it a couple times. Maybe I'm being too impatient. Well, now it looks a lot better. Still not in closed loop. There it goes. Now it's in closed loop. I don't know why now it looks okay. Yeah, that's good closed loop. Yeah, I don't know what all that wasted time was about, but I'm gonna take the load down here. Take it down to... And now I want to see the shift points. I want to see it shift into overdrive and lockup. Go ahead. It all looks like it's working good now. I think maybe my impatience just got the best of me. I'm used to newer cars that go into closed loop in like 10 seconds and just stay there. These older things, they're not that good about, you know, staying locked into closed loop. It was more about getting it to run good back then. These older motors didn't like to be lean all the time. But basically, if you're not familiar with closed loop feedback operation, this is what the O2 sensor signal should look like. It leans it out until it gets to about 0.2, then it starts richening it up until it gets to 0.8, and it keeps it in this narrow window of fuel control. This is a very narrow window of fuel control. So I think we're ready to recap this. I feel pretty good about it. We had all of our transmission shifts, our overdrive lockout worked. Seems to be in closed loop if I'm patient and give it enough time to do so. So yeah, I think I can recap this and put it back together, and the owner of this vehicle will be happy that they can pull up to the gas station in style again. I got the capacitors here. We're going to recap this thing, put it back together, put it in, just double check our closed loop operation, make sure it runs good, in good fuel control, and I think we're a fix here. Here it is all recapped. It's a real pain to work on this conformal coated stuff, but you know what? It's good. It's recapped. I checked all these caps before I put them in. So just put it back together and stick it in the vehicle and look at the emissions and the shifting and ship it. Someone will be very happy. There it is. I tag it like a gangsta. So I'm going to put it back in and we'll see how it works. So the reason why I'm interested in closed loop is because that's when everything is in good operating condition, all the information from all the other sensors, it'll go into closed loop. That's the ultimate end of line fuel fine tuning. So we know if it's in closed loop and the transmission shifting right, we got a good fix. The original computer's back in. I think what I'm going to do is I'm going to start it, let it run, because it gets a barometric pressure reading right now. I'm going to let it run and warm up a little bit and then shut it off. And I think it kind of needs to store some kind of memory before it'll go into closed loop. I've noticed that on these before. I work on a lot of these. Why, I don't know, but yeah, I can smell right now it's rich. So again, we're pig rich, and maybe that's because it lost memory. So we'll take it on a little drive here and we'll stop it and restart it and see if it goes into closed loop. All right. See if it goes into closed loop now. Yeah, this thing is a trip. That looks good. But it should stay locked at like 0 CO. Like that. That looks good. Because this has a big air pump and cat on it. Yeah, it's good now. It's in closed loop. I don't know why it did it on the second restart both times. What a waste of time. But it's good. It's recapped. It's back together. It's ready to roll. Okay, we'll take it up to like 50, 55 here and I'll let you watch all the numbers. 10 horsepower load, that's a lot. Looks good, shifts good, runs good. It's a fix. So that's a solid fix.